Hello dear students. In our previous class we have learned how to solve a system of linear equations by using matrix inversion method. In our class we have seen how to solve two equations, means when two variables are there. Today we are going to solve the problems which are having three equations or three variables. Here we have one example, example number 28 from page number 134. Solve the following system of equations by matrix method. So whether they are using matrix method or using inverse method, all methods are same, you don't need to get confused. So we have three system of linear equations. These three system of linear equations we should convert in the form of matrix form, then we continue the procedure. So whatever the procedure we have followed for two variables, the same procedure we are going to follow for three variables also. There is no change in the procedure, only the difference you can find. There we have two variables, here we are having three variables. Now let us see how to solve the system of linear equation when three variables are there. So the solution we are going to do here, given equations are, what are the given equations we have? 3x minus 2y plus 3z is equal to 8. 2x plus y minus z is equal to 1. 4x minus 3y plus 2z is equal to 4. So these are the three equations we have. Now we need to convert in the form of matrices. So converting into matrix equation form. Matrix equation form. Now the given system of linear equation we are going to convert in the form of matrix equation form. You know how to convert it. How to convert it? First we collect all the coefficients of a variable. Here the variable is 3, coefficient is 3, minus 2 and 3. So 3 minus 2, 3. Here I have 2, 1 minus 1. 2, 1 minus 1. Here 4 minus 3 and 2. 4 minus 3 and 2. And the variables we have x, y, z. And the constants we have 8, 1, 4. So it is in the form of Ax is equal to b. It is in the form of Ax is equal to b. Here coefficient matrix we consider as A, variable matrix we consider as X, constant matrix we consider as B, where A is equal to, what is the matrix here we have? 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2. When we have the matrix A, we need to find its determinant. Now we go for det. 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 3. So as we know that this determinant can be calculated in 6 different ways. Either using 3 rows or 3 columns, we can expand it and we are able to find the determinant. So the determinant can be found using either row 1 expansion or row 2 expansion or row 3 expansion or column 1 expansion or column 2 expansion or column 3 expansion. We have 6 ways of finding the determinant. Now usually we take row 1 expansion only. Now here also I am expanding the determinant with row 1. So by considering the row 1, as we know that when we are expanding with row 1, the first we have positive, next we have negative, next we have positive. Alternative signs will come. Now you can understand why these alternate signs will come. We have seen minors and cofactors. When we calculate cofactors, you are having plus or minus alternatively. So with that concept, here the first value will come plus, next minus, next plus, like that alternative signs will come. That is the secret behind. So initially you don't know why the plus minus plus will come. Now you know that because cofactor concept is there. Using that minus and cofactors, we are having plus, minus and plus symbols. Now expanding with 3. When we are expanding with 3, as you know that leaving the row and leaving the column, we have a 2 by 2 matrix. What is that? 1 minus 1 minus 3 2. 1 minus 1 minus 3 2 minus. Now here I have the element minus 2. When we are talking about minus 2, leaving the corresponding row, leaving the corresponding column, what are the elements we have? 2 minus 1 4 2. I have 2 minus 1 4 2. Now we talk about plus 3. When we talk about plus 3, again leaving the row, leaving the column, we have 2 1 4 minus 3. 2 1 4 minus 3. Now you expand 3. Here 1 2 0 2 minus 3 into minus 1 plus 3. Minus of minus becomes plus 2. Here also 2 2 0 4 minus 4 into minus 1 minus 4. So minus of minus becomes plus 4. And here I have plus 3. 2 into minus 3 minus 6. 4 into 1 minus 4. So 3 into minus 1, 2 into 8, 3 into minus 10. We have minus 3 plus 16 minus 30. Total minus 33 plus 16. We have minus 17, which is not equal to 0. So once we are calculating the determinant, minus 30 and minus 3 makes minus 33. Minus 33 plus 16 gives us minus 70, which is not equal to 0. When the determinant is not equal to 0, we can say that it is a non-singular matrix. When it is a non-singular matrix, A inverse exists. So we have to know that whether the determinant is 0 or not. When the determinant is not equal to 0, then only we are able to continue. Now when determinant is not equal to 0, what exists? A inverse exists. When A inverse exists means, now we can say these equations are consistent equations. As we know that consistent and inconsistent. Consistent where we have a solution. Inconsistent where we don't have a solution. Now here the system of equations are nothing but consistent. Now we can find the solution for the system of equations. Now how to find it? Now let us see here. Now when I know that A is not equal to 0, now I can say that A is a non-singular matrix. A is a non-singular matrix. That is, A inverse exists. A inverse exist. That is, the given system of equations are consistent. System of equations are consistent. Now, when we need to find the A inverse, what is required for us? Adjoint of A. Now, we need to find the adjoint of A matrix. How to find the adjoint of A matrix? Let me explain. Now, adjoint of A. So for this, I will tell you a simple technique to you all. Earlier, we have calculated the adjoint of A, finding cofactors for every element. Then we frame the adjoint of A matrix. That is the procedure we know. Adjoint of A matrix, how you will get? First we find cofactors. With that we have a matrix. Transpose of cofactor matrix is nothing but adjoint of A. That lengthy procedure we are having. Now, what I am going to explain to you, instead of finding every element cofactor, then finding cofactors matrix, then finding its a transpose, doing all unnecessary calculation, a simple technique we have. Let us just observe it. How to find the adjoint of A. Very easily we can do it. It is not at all a difficult task. So, as I told you first, we have 3 by 3 square matrix. This is the that matrix A. We have 3 by 3 order, means 9 elements are there. We need to find 9 cofactors. Now directly I am finding the cofactors. While finding the cofactor, we know that the symbols will come alternatively. So first here I will get plus. Here I have some value. Next I have minus. Next I have plus. Again here minus, plus, plus, minus, minus, plus. This we know. So like this we have a matrix. Now we don't know what are the values are there within the boxes. Now this is about adjoint of A. As we know that adjoint of A is nothing but what? Transpose. Means rows become column, columns become rows. Now first I am talking about first row. What is the first element? 3. When you want to find the cofactor of 3, what we do here? Just leaving the respective row, respective column, we have a determinant. What is the determinant? We have 1 minus 1 minus 3, 2. 1 minus 1 minus 3, 2. That is the determinant we have. Now, directly I am explaining to you, just concentrate properly. When we are talking about 3, we have this is the determinant. Now directly 1 2s are 2. 1 2s are 2 minus. Now minus 3 into minus 1 plus 3. This is the first cofactor I have. Next, when we are talking about minus 2, when we are talking about minus 2, now we are observing. As we know that while finding the cofactor of minus 2, we need to eliminate the respective row and the respective column. What else we have? 2 minus 1, 4, 2. Now 2 2s are 4. Now where I need to write? Now I told you transpose. Transpose means rows will change as columns. So here I have to write 4. So 2 2s are 4 minus 4 into minus 1 minus 4. So here I have minus 4. Otherwise simply you can write minus or minus plus 4. Now coming to the third element. When we talk about 3, Leaving the respect to row and respect to column, we have 2, 1, 4, minus 3. Now 2 into minus 3, minus 6, minus 4 into 1, 4. Next. So first row completed. Now we talk about second row. What is the first element? We have 2. So leaving the corresponding column and corresponding row, you have 2, 3, minus 3 and 2. So minus 2 into 2, minus 4. Minus 3 into 3, minus 9. So minus of minus plus 9. Now when we talk about 1, leaving the corresponding row and corresponding column, we have 3, 3, 4, 2. 3 2s are 6. Minus 4 3s are 12. Now talking about minus 1. Leaving the corresponding row, leaving the corresponding column. 3 into minus 3. Minus 9. Minus 4 into minus 2. Minus 8. So minus of minus becomes plus 8. Now coming to the third row. First we are talking about 4. Leaving the corresponding row, corresponding column, we have minus 2, 3, 1, minus 1. Minus 2 into minus 1, plus 2. Minus 1 3s are 3. Now we are talking about minus 3. Leaving the corresponding row, corresponding column. 3, 3, 2, minus 1. So 3 into minus 1, minus 3. 2 3s are 6. Now we talk about last element 2. Leaving the corresponding row, corresponding column, we have 3, minus 2, 2, 1. 3 1s are 3. Minus 2 into minus 2, minus 4. So minus of minus becomes plus 4. So directly we are finding the adjoint of a matrix. So when we are talking about row 1 cofactor we are writing as column 1. Row 2 cofactors we are writing as column 2. Row 3 cofactors we are writing as column 3. So cofactors completed and transpose also completed. Now just we need to simplify. So while calculating cofactors, you have to be very careful. If you are unable to understand this method, you can follow your regular method. Nothing is wrong. Just the length of the problem will increase. So you need to calculate individual cofactors, then you need to frame the cofactor matrix, then you need to take the transposition. Instead of doing all those things, simply I am explaining in another way. This is about adjoint of A. Now let us see what is the final adjoint of A we have. Adjoint of A is equal to, see here, 2 minus 3 minus 1, 9 minus 4 plus 5, before you have minus, so minus 5, 2 minus 3 minus 1, 4 plus 4, 8, minus 8, 6 minus 12, minus 6, minus 3 minus 6, minus 9, minus of minus, plus 9, minus 6 minus 4, minus 10, minus 9 plus 8, minus 1, minus of minus, plus 1, 3 plus 4, 7. This is about adjoint of A. We know that, what we know? We know that A inverse is equal to 1 by that A into adjoint of A, that is 1 by that A we have minus 17. Now adjoint of A, here I have minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 7. If you want this minus can be multiplied inside. So finally we have 1 by 17 into minus of minus plus, 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 minus of plus minus, minus of minus plus, minus of plus minus, minus of plus minus. So this is about A inverse. Now what we have? A inverse. Now we need to find the values of x, y and z. How to find? We know another formula also. So earlier we have a matrix equation form. We have matrix equation form. We also know that what we know, Ax is equal to b. That implies x is equal to A inverse into b. Now let us see that x is equal to A inverse. What we have A inverse? 1 by 17 into 1, 5, 1, 8, 6, minus 9, 10, minus 1 and minus 7. And the matrix B. Matrix B is nothing but what? Constant matrix. What are the constants we have? 8, 1 and 4. So we have 8, 1, 4. Now we should multiply. So 1 by 17. As we know that, what we know? Row 1 elements will multiply with column 1 elements. So 1 8s are 8, 5 1s are 5, 1 4s are 4. Next, row 2 elements will also multiply with column 1 elements. 8 8s are 64, 6 1s are 6, minus 9 into 4, minus 36. Now row 3 elements are also multiplied with column 1 elements. 10 8s are 80, minus 1 into 1, minus 1, minus 7 into 4, minus 28. So that is equal to 1 by 17 into, now you see, 8 plus 5, 13, 13 plus 4, 17, 64 plus 6, 70, 70 minus 36, 34, 80 minus 1, 79, 79 minus 28, otherwise simply 80 minus 29. How much will come? 51 will come. 51. Still we have simplification. Now that implies x is equal to, now this 1 by 17 will multiply inside. So what we have? We have 17 by 17, 34 by 17, 51 by 17. While simplifying the values, we have 17 by 17 1, 34 by 17 2, 51 by 17 is 3. Now what is the x here? X indicates the variable matrix. So x, y, z is equal to 1, 2, 3. As we know that these two matrices are nothing but equal. When these two matrices are equal, their corresponding elements are also equal. Means finally we have the value of x is equal to 1, the value of y is equal to 2, and the value of z is equal to 3. So this is our procedure to find the x, y, z. Even you can have your verification also, whether our answers are correct or not. Verification. How to verify? substitute these x, y, z values in the given equations. Substitute the x, y, z values either in the equation, any equation you substitute. Definitely these x, y, z values should satisfy. When it satisfies, our answer is correct. When it doesn't satisfy, our answers are wrong. That verification also you can do it, so that you no need to depend on anyone and you no need to hesitate whether our answer is correct or not. You yourself, you can check, you can assess your answer whether it is right or wrong. Let us see the verification. Now I am doing the verification. I can do the verification. I have the first equation. This is my first equation. 3x minus 2y plus 3z is equal to 8. So 3 into 1, 2 into 2 plus 3 into 3 is equal to 0, because I got x value as 1, y value as 2, z value as 3. So 3 1s are 3, 2 2s are 4, 3 3s are 9 is equal to 8. Now you see 9 plus 3, 12, 12 minus 4, 8. 8 is equal to 8, which is true. So this is just we are verifying equation number 1. Similarly, you can verify for the remaining 2 also. Definitely those 2 equations also will get true statement. So this is the procedure how to solve a system of linear equation when we have 3 variables. So there is no much difference between system of linear equations in 2 variables, system of linear equations in 3 variables. Let us see one more problem so that you can have more clarity. Still, if you have any doubt finding the adjoint of A also, you can get it more clarity. Here we have example number 29. It is just like a word problem. Let me read out the question. The sum of 3 numbers is 6. Sum of 3 numbers is 6. If we multiply the third number by 3, we multiply third number by 3 and added second number to it, will get 11. By adding first and third numbers, we get double of the second number. Represent it algebraically and find the numbers using matrix method. So here first initially they mentioned that sum of 3 numbers. We don't know what are those 3 numbers. Those 3 numbers we should find. Now how to do this problem? So first reading the question is important. Understanding the question is important. Then by understanding the question, we need to frame the equations are another important. Once if you fail to frame the proper equations, then your entire answer is wrong. So framing the system of linear equations by reading the question is most important thing. So let the 3 numbers are x comma y comma z. Now according to the problem, what is given according to the problem? They said that sum of 3 numbers is 6. X plus y plus z is equal to 6. This is first equation. And continuation they have given that multiply third number by 3 and added second number to it, we get 11. Third number means z, we should multiply with 3 and this should add it to the second number means y. So y plus 3z is equal to 11. So z is the third number. Third number is multiplied by 3 and added to the second number, so that we have 11. Again, continuation. By adding first number and third number, by adding first and third numbers, we get double of the second number. First number is x, third number is z. By adding these two, we get double of the second number. Double of the second number. So this is the way, by reading the question, we need to frame the system of equations. Now, these equations we should convert into a proper form. How to convert it? The first equation will be as it is. The second equation, when we observe the second equation, I have only the variable y and z, but I don't have the x. Now what to do? I can take zx as with 0 coefficient. 0 into x plus y plus 3z is equal to 11. Again, the third equation, plus 2y, it should come to left hand side. What I have here, x minus 2y plus z is equal to 0. Now we have a proper equation. What is the first equation? The first equation I have x plus y plus z is equal to 6. Now 0 into x plus y plus 3z is equal to 11. X minus 2y plus z is equal to 0. Now I have three system of linear equation. Now I can solve. So what we do? We have to make in matrix form. Let us convert it. Convert them into matrix equation form. Once if you make it, what we get? We get here coefficient we need to take 1, 1, 1, 0, 1, 3, 1, minus 2, 1. This is about coefficient matrix. Next we have variable matrix x, y, z. Next we have the constants 6, 11 and 0. These are the constant matrix. So as we know that it is in the form of what? Ax is equal to b. It is in the form of what? Ax is equal to b. If you want, you can assume it as equation number 1 also. Where a is equal to, what is the A matrix? 1, 1, 1, 0, 1, 3, 1, minus 2, 1. Now we need to find its determinant. That A is equal to that 1, 1, 1, 0, 1, 3, 1, minus 2 and 1. That implies. Now you can expand with row 1 or you can expand with column 1 as you like, not at all a problem. Now I am going with column 1 expand because I have 0. That's why I am going with column 1. Once you are going with column 1, here you have plus, minus, plus. So when we talk about 1, leaving the respective row and respective column, we have 1, 3, minus 2, 1. 1, 3, minus 2, 1. 0 I am not considering because anyway 0 and anything is 0. That I am going with 1. So again I have plus 1. So leaving this respect to column and respect to row, we have 1, 1, 1, 3. 1, 1, 1, 3. Now this we need to calculate. That implies that A is equal to 1 into 1 ones are 1 minus 2 into 3 minus 6, so minus of minus plus 6 plus 1 into 1 3s are 3 minus 1 ones are 1. So finally that A is equal to 7 plus 2 which is equal to 9 which is not equal to 0. When the determinant is not equal to 0, what we get? We get A inverse. When we get A inverse, we have a solution. When we have a solution, these equations are nothing but called consistent equations. So that is A is a non-singular matrix. That is A inverse exists. A inverse exists. That is the system of equations. The system of equations are consistent. The system of equations are consistent. Now, what we need to find? First, we need to find A inverse. To find A inverse, what is required for us? Adjoint of A. Now, I am finding adjoint of A. As I told you, adjoint of A. How to find? First, we take plus, minus, plus, minus, plus, plus, minus, minus, plus. First, we take with empty brackets. Now, we find the values. How to find the values? Now, first I am talking about row 1. When we are talking about row 1, what is the first element we have? 1. When we are finding cofactor of 1, as we know that, leaving the respective row and respective column. By leaving the first row and first column, what we have? 1, 3, minus 2, 1. So, 1 ones are 1. Minus 2 into 3, minus 6, minus 7, minus plus 6. Now when we talk about 1, leaving the respective row, leaving the respective column, what we have? 0, 3, 1 and 1 we have. 0, 3, 1, 1. So 0 into 1, 0. Where we need to write? Here or here? We should write here because the rows will convert as columns. Minus 1 into 3, 3. When we talk about 1, what we need to do? Again, leaving the respective row, leaving the respective column. What we have? 0, 1, 1, minus 2. So 0 into minus 2 is 0, minus 1 ones are 1. So first row completed. Now we go for second row. When we talk about 0, leaving the respective row, leaving the respective column, we have 1, 1, minus 2, 1. So 1 into 1, 1, minus 2 into 1, plus 2. Now talking about 1, leaving the respective row and respective column, 1, 1, 1, 1. So 1 ones are 1, minus 1 ones are 1, 1 minus 1. Now we talk about 3, leaving the respective row, respective column, we have 1, 1, 1, minus 2. 1 into minus 2, minus 2, 1 into 1, minus 1. Now coming to the last row, what we have? 1, minus 2, 1. When we talk about 1, leaving the respective row, leaving the respective column, we have only these elements 1, 1, 1, 3. 1 3s are 3 minus 1 1s are 1. Now talking about minus 2, leaving the respective row and respective column, we have 1, 1, 0, 3. We have 1, 1, 0, 3. So 1 3s are 3 minus 0 1s are 0. 3 minus 0. Next, last element. Here we have the element 1. So leaving the respective row and respective column, what we have? These are the elements 1, 1, 0, 1. 1 1s are 1, minus 0 1s are 0. 1 minus 0. So this is about to find adjoint of it. You have to do a little bit carefully. Now that is equal to, let us simplify. 1 plus 6, 7. 2 plus 1, 3. Minus 3. 3 minus 1, 2. Minus of minus, plus 3. 1 minus 1, 0. Minus 3. Minus 1. Minus 2 minus 1, minus 3. Minus of minus, plus 3. And 1. This is about adjoint of A. This is about adjoint of A. Once we know that adjoint of A, now we can find A inverse. Then we can find the matrix. What matrix? Coefficient matrix. Sorry, variable matrix we can find. Let us see here how to find it. Now A inverse is equal to 1 by A into adjoint of A, that is 1 by 9. That A, earlier we had the value is 9, so 1 by 9 adjoint of A. Just so we have a adjoint of A. What is that? 7 minus 3, 2, 0, sorry, 3, 0, minus 3, minus 1, 3 and 1. From equation 1, what is equation 1? We have Ax is equal to B. That means x is nothing but A inverse into B. That is nothing but x is equal to A inverse. Just now we have A inverse. 1 by 9 into 7 minus 3, 2, 3, 0, minus 3, minus 1, 3, 1. And B is nothing but constant value. 6, 11, 0. 6, 11, 0. Now these two we need to multiply. When we multiply, that implies x is equal to 1 by 9. As we know that the first row will multiply with first column. So we have 7 into 6, 7 6 are 42, minus 3 into 11, minus 33, 2 into 0, 0. Now the row 2 elements will multiply with column 1 element. 3 into 6, 3 6 are 18, 0 into 11, 0, minus 3 into 0, 0. Now the last row will multiply with column. Minus 1 into 6, minus 6, 3 into 11, plus 33, 1 into 0, 0. Now 1 by 9 is 42 minus 33. How much we got? 9. 18. 33 minus 6. 27. This 1 by 9 also multiplies inside. So that you have 9 by 9. 18 by 9. 27 by 9. Which gives us 1, 2, 3. What is these values? Matrix X. Matrix X is nothing but what? Variable matrix. Means the variable matrix we have X, Y, Z, that is equal to 1, 2, 3. So that we can compare the corresponding elements. We have X is equal to 1, Y is equal to 2 and Z is equal to 3. So finally we have the three numbers. The required three numbers are X is equal to 1, Y is equal to 2 and Z is equal to 3. This is the way we can simplify or we can solve the system of linear equation either in 2 variables or in 3 variables. This is our last concept of determinant. With this concept successfully we have completed the second chapter. Second chapter in the sense our finished concept. As the serial number, it is the fourth chapter. Earlier we have finished matrices. Now we have completed the second chapter, determinants. So matrices chapter is complete and determinants chapter is also complete. These two chapters, why we have chosen before in the sense, these two are very easy chapters. Easily you can score nearly 10 to 12 marks from these two chapters. So hope you can understand all these concepts. Still, if you have any doubts, you can call me at any time.